Hi everyone. Today we'll discuss about the next question of the two-pointer approach. So in the previous video, I have discussed about the what is two-pointer approach, and we have also discussed the first question. You can see we have marked it as the discussed. So let me update the color to the green color. That means we have covered this question already. So if you haven't watched that video, I would highly recommend you please go and check out that video. But that is the basic. That is the starting for the two-pointer. How two-pointer works. I have done the dry run for the example with the help of example, low pointer, high pointer. Everything I have explained there. So in that video, I also gave you the assignment. You need to do these 5 questions. At least try once. Okay. Now today, what I'll tell you that these 2 questions are very similar to the first question. Okay, so still you can try it. Okay, I'll give you some more time. Till then, I'll discuss the question of this triplet one. Okay, so today I will discuss this one, and then these 2 questions are very much similar to the fourth question. So this is our target for today. All right. Once you will be able to understand this question, these fifth and sixth will be very easy for you. Okay, so let's jump to the problem now. What is this problem? What this problem is talking about is that you need to find a triplet that sum to a given value. Means we will have 2 integers. We will have the input as the 2 parameters. One is our array. Second is the key. Let's say we have array as 10, 20, 30, 40, 50, 60, 70 and key is 80. Okay, key is 80. Now one thing, okay, let me just change the array such that you don't think that array will always be sorted. It is not necessary. Okay, now here you need to find the triplet whose sum is 80. So 10, 20 and 50 total sum is 80. So you just need to return this particular triplet as the answer. That is the question. Okay, now the first question, the first method. Okay, just pause the video and think about the solution which is coming to your mind. Simplest approach. Don't think about how much time that will take. Are you able to solve the problem or not? That is the most important thing. So method one is think about the solution. Think about the simplest solution. Don't think about the time. So the first solution which is coming to my mind is I'll run 3 loops, one for this one, another for this one, and third for this one. I'll calculate the sum of all 3 and we'll get the answer. So we just need to run 3 loops. Loop 1, inside that one we have loop 2, then we have the loop 3, and what we need to do here is just calculate the sum of array of, let's say I, array of j, array of k. Okay, when this is equals to the key, that means we got the triplet in the array of I, j and k. Alright, I think it is making sense to you guys. So but this approach, time complexity will be O of n cube because we are running the 3 loops here. Now we will jump to the some better approach. Let's think about the better solution. Alright. So we have seen the first approach, which is the brute force solution, that is taking the O of n cube. Okay. So can we optimize it? Let's think about the solution. So what we are doing here is we want 3 numbers. Okay, we want 3 numbers. Just check for this line. It's very important. So here array of I, j and k. Summation of these 3 we are looking for k. Okay. So can I write the same line? So array of I plus array of j. Okay. Can I write this as the key? Sorry, so 1 second. Let me just try to write array of k. Can I write this as the key minus array of I plus j. Okay, so once we will write these two, I can say that third element will be key minus summation of two numbers. Okay, so can we avoid the loop for third one? Because these two we know, okay, these two we can get from two loops, and third element we already know how, key minus summation of those two numbers. The only thing which we need to do is we need to apply the search that this third element is present in the array or not. Okay, so let's jump to the solution. What I am saying is, method 2, I'll just run the two loops. Okay, let's say for I 0, I less than n, I plus plus. One more loop, j 0, j less than n, j plus plus. Alright, this is the another approach. So here what I am doing, I'll calculate the sum of these two, which is nothing but the array of I plus array of j. Alright, array of I plus array of j. That is the simple logic. So what will be the third number? Third number will be key minus sum of 2. Okay, sum of 2. Now I just need to search if third is present in the array. That means I got the triplet. In the array, that means I got the triplet. I got the answer. Okay. So how to search? Now for searching there are multiple approaches. If array is not sorted, searching will take off and time. If array is sorted, with the help of binary search, searching will take off long and. Is there any better way? Yes, we have. We have the concept of hash map. If you will keep storing the data, let's say, okay, you ran the loop, you store all the data in the hash map. Okay, directly you can search the third element. How you will search? If hash map of third is present in the map, that means, so we can get the third element is present in the array or not in constant time. In constant time using hash map. Understood? This is also a very good approach actually. So in this approach, we have improved our time to of n square, which is very good. But only problem with this approach is we are using extra memory, which is nothing but of n. Alright, because we are storing the data into the hash map. So, but I would say you should tell this approach to the interviewer. He will be happy with the solution. Alright. Now, do you think can we still optimize it? Try it. Pause the video and think about the solution. Can we still somehow remove this space complexity and can solve the problem? So, okay, yeah, third approach which is coming to my mind is yes, we can do it. We can still optimize it. How? So, using my favorite solution, favorite technique actually, not solution, which is two-pointer approach. Okay. Now, first thing, for two-pointer, your array should be sorted. Okay. Let us do that. So, for step 1, sort the array. Step 2, just run a loop. Okay. Let's say we are running for int I0, I less than n, I plus plus. That is the loop. Now, for each I will take 2 pointers. Low will be I plus 1, high will be your last element of the array. So what we have seen in the 2 pointer, we used to take low and high. We will calculate the sum of these two numbers. and we will get the answer, right? I'll show you one problem which we have discussed already. This is the problem which we have discussed. Alright. So in this problem we have solved using the two-pointer approach, where we need to get the summation of those two numbers equals to this one. We have solved it with the help of two-pointer in the of and time. So that is the brute force, okay? But we also have written the code for the optimized one with the help of two-pointer. You can check my previous video for that. So this problem, what is this problem now? This problem becomes that, hey, now let's say new key, okay? New key, I'm giving the name key minus array of I. Okay, so this becomes the same problem. You need to find two elements whose sum is new key. The third is already here. So that this part, these two part, we can do in of and time. Of and time, and there is one outer loop. So n multiplied by n. So this is the time complexity. This is the time complexity here. And here we are space complexity is nothing but because we are just using two variables. So space complexity is nothing but of 1. Alright, let's jump to the coding part. We'll not waste our time. So let's jump to the coding part. So this is the this is the approach we have discussed, that if you want to get a pair whose sum is this key, this is the approach I have discussed. It will just take of and time. Of and time when the array is sorted. Okay, when the array is sorted. Yeah. So in this approach, we have already sorted the array. Alright. So once array is already sorted, then this will be in of n. It's an outer loop, so n square. Let's jump to the code. So I'll create one class. Okay, I'll create one class. Let's say the triplet with sum is given as key. Okay, I'll take the same array, which is this one. Alright, let me just add this one here just for our reference. I'll declare one array which is nothing but the same 20, 10, 40, 30, 50, 60, 70. Alright, this is our array. Sorry. This is our array, and this is our key, which is nothing but 80. Alright, how many elements we have? So we have 7 elements. So n is the size of array, which is 7. What I am saying, first step we need to sort the array. Arrays.sort array. Done. Sorting is done. We'll run one loop as discussed. I0, I less than n, I plus plus. Alright. Here what you need to do, you need to take two pointers, which is I plus 1, and high will be your last element, which is n minus 1. Okay. What you will do if low is less than high, that is the important thing, then only I will go forward. I'll calculate the sum, which is nothing but, here let me just get the new sum. Okay, new sum which I want to get is key minus array of I. Okay, perfect. Here I'll calculate the sum of low plus high. This is the same approach actually. What you will compare? If sum is greater than the new sum, okay, means this is greater. Okay, so I want to make it same as new sum, so I need to decrease this sum somehow. For decreasing the sum, we know we need to reduce the higher pointer, else we need to increment the low pointer. Yeah, see, one thing we have missed here, we haven't compared the sum. It might be the same as Newsom, right? So as if we need to do those things, here we got the answer. What you will do here, system dot out dot println. Okay, you can print the triplet is, you can say one is your area of I. Let me get the comma. Next will be your area of low. Next will be your area of high. Understood? So that is the thing. Just break out of the loop. Now one thing. Here we are just coming out of this loop only. We are not coming out of the outer loop. So that problem also we need to solve. So what we can do, I take one variable is found. Okay, this variable will be false. Let's say here I'll just do is found equals to true. Okay, outside this loop just apply one check. If is found is true, just break out of the loop. Okay, now just run it. So we got 10, 20 and 50. So we got 10, 20 and 50. That is the answer, right? We are looking for triplet whose sum is 80. So 10, 20 and 50. Clear? That was the all about this question. I would say now, what is your next assignment is you need to go and solve these two questions. So let me update the status. Since we have discussed it now, I'll update it. Discussed. Alright. So just give a try to these two questions. They are very similar to this one. Okay, they are very similar to this one. Okay, thank you so much everyone. If you like my videos, my content, or if you want to suggest me anything how to improve, where I can improve, please comment down and share the video content with your friends, with your colleague everywhere, so that you can learn with me. I'll try my best to explain you guys the concept of the programming, dynamic programming, and data structure algorithms in the best possible way. Okay, so like, share, subscribe. Thank you everyone.